This is an example slide. Hiring managers are asked to identify the biggest mistakes that job applicants make during an interview, and the table below is based on their responses. Based on data from an ADECO survey, does the table below describe a probability distribution? What do you think? Yes? No? Let's check. First, is X a numerical random variable? No. X is categorical. It's a categorical random variable. And so categorical random variables do not have distributions that we will be discussing in this class. So this is no, this does not describe a probability distribution. And there's another reason it doesn't describe a probability distribution. They sum up, the probabilities sum up to 1.75. That's greater than 1. That you can't have that. What about the third condition? Are each one of these individually less than or equal to 1? Well, yes, it's got that going for it. But that's it. So 2 strikes here. It's not numerical. And this one here, another strike, sums to greater than 1. All right, and that's that. Here is an example. Finding the mean, variance, and standard deviation. The table describes the probability distribution for the number of heads when 2 coins are tossed. All right, it's our old friend, the same distribution as before. Find the mean, variance, and standard deviation of the probability distribution when 2 coins are, and then toss is probably right there. I don't know what. I must have missed this making the slides, but I don't care to. What we have here is fine. All right. So let's start with this. So the mean, okay, here I go. I'm going to do the mean. The mean is defined as the sum of x times the probability, the sum of x times the probability of that value. So what's my first x? 0. 0 is my first x. So 0 times, what's the probability of 0? 0 times 0.25. Plus, what's my next value? 1. 1 is the next value. There's the first value, second value, third value, and that's it. So I've got 1 times the probability of 1. Well, what is the probability of getting 1 head? That's going to be 0.5. So 0.5. Plus 2. 2 is my second value. That's the third value is 2. So it's going to be 2. What's the probability of getting 2? That's going to be 0.25. So 2 times 1/4. All right, I add all these up together. I get 0 plus 1/2 plus 0.5, right? Plus 1/2 again. And in the end, what I get is 1. Okay, so that's what I get is 1. Notice that's different than if I were to just add all these up together and divide by, let's see now. If I were actually to add these all up together, I would get 3 divided by 3, which would also be 1. But that's not the way to do it, as we'll see with another example. Okay. So, finding the mean, variance, and standard deviation. Okay, here's the interpretation of that. When tossing 2 coins, so we found the mean. Oh, wait a minute. We just found the mean. The mean was 1. Yeah. The mean was 1. So what's the variance going to be? Well, the variance, which is sigma squared, is going to equal the sum of x minus the mean, mu, which was 1, times the probability of x. And I square that deviation. So let's see what we get. So that's going to be, the first one is going to be x equals 0. So that's going to be 0 minus 1 squared times the probability of 1, times the probability of getting 0, which is 1/4. I just prefer to write it in fractions. Plus, now I'm on the x equals 1 outcome. So this is going to be 1 minus 1 squared times the probability of getting 1, which is 1/2. And there's that. And then I end up getting the next one, which is what? 1 minus, 2 minus 1. This is x equals 2. This is the x, y equals 2 outcome now. I square that, and I multiply it by the probability of getting 2. And that's 1/4. Okay, and so that equals, well, this one here is 1/4 plus 0 plus 1/4, which is 1/2. That's the variance. The standard deviation is the square root of the variance, which is 1 over the square root of 2. And so that's the variance. All right, so what's the interpretation? When tossing 2 coins, the mean number of heads is 1. That's the expected number of heads. If I repeated that many, many times, excuse me, I would expect to average 1 heads per toss. Excuse me. Okay. Also, the expected value of the number of heads when 2 coins are tossed is 1 head. Okay. So the mean number of heads is 1. And the variance is 0.5. That's what we found. And the standard deviation is 0.7, which is 1 over the square root of, which is about 1 over the square root of 2. Notice this very interesting unit here, heads squared. Okay. Also, the expected value is going to be 1 heads. All right. And so if we collected data on a large number of rolls, we would expect to get 1 head per flip. Okay, here's an example. Identifying significant results with the range rule of thumb. We found that when tossing 2 coins, the number of heads is mu equals 1 head, and the standard deviation is 0.7 head. Use those results and the range rule of thumb to determine whether 2 heads is a significantly high number of heads. Now, it should not be the case, but let's just see. The question is it significantly high? Well, it's going to be significantly high if it's bigger than mu times 2 sigma, which equals 1 plus 0.7 times 2, which is 2.4. 2 is not bigger than 2.4, so it is not significantly high. Yep. So there you go. Okay, so if we look at this example, be a better. You have $5 to place on a bet in the Golden Nugget Casino in Las Vegas. You have narrowed your choice to one of 2 bets. Okay, so you can either go to the roulette table and bet on number 7 in the roulette, Or you could go to the craps table and bet on the pass line, whatever that means, in the dice game of craps. Okay. So let's talk about being a better. Let's talk about this bet right here. So if you bet $5 on 7, bet $5 on 7, then your probability of losing $5. Okay, so the X is going to be your change in wealth. And so, what are the possibilities? Well, X could equal -5, a change in wealth of -$5. The probability of that happening is 37 out of 38. Why? Because there's 38 tiles or squares on the roulette table, or roulette wheel, one of which is 7, and the other ones are a loss. But you could also gain $175 if the little marble lands on 7. And so the probability of that happening is 1 in 38. Okay, find your expected value. Find your expected value if you bet $5 on number 7 in roulette. So the mean, the expected payoff, is going to be -5 times the probability of -5 plus 175 times the probability of the of X equaling 175. And so that equals -5 times 37 over 38 plus 175 times 1 over 30. Excuse me, over 38. Now 37 times 5 is 150 plus 35, which is 185. So this is a negative 180, negative 185 over 38 plus 175 over 38, which is negative 10 over 38, which is, if I grab one of my TI 73 calculators, I get negative 10 divided by 38 gives me negative 0.263. Okay, but what is that? What's the units on that? Well, what's the units on X? -$5, $75. So all of these were dollars. Now, probability has no unit. That's a ratio. It has no unit. And so that's going to give us $0.26 or negative 26.3 cents. So that means that if I did that many times, on average, I would lose. Now, this is only on average, right? On average, I would only lose 26 cents each time I did it. And so if I did it 100 times, I would probably end up losing around $26. And if I did this 1,000 times, I just bet all day, I'd probably end up losing $263. I'll bet it would be quite close to that. So maybe I would win maybe twice or something. Twice or maybe 3 times I would win if I did this 1,000 times. Maybe twice or 3 times I would win, and I would lose a whole lot of money. Actually, no, right? Because I end up only losing $263, and I end up paying $5 every time I lose. So I probably would win a bit, right? But overall, it would not be a good day. I'd end up losing $263 for betting 1,000 times. All right, let's take a look at the pass line, the craps game. If you bet $5 on the pass line in the dice game of craps, the probability of losing $5. Okay, so here we go. So X, you have the chance of losing $5, and that probability of -5 is 251 over 400 over 495. All right. And the probability of making a net gain of $5 is the other one, 244 over 495. If you bet $5 on the pass line and win, you are given $10. Yay. That includes your bet, so that your net gain is $5. Okay, so what does that mean? So that means X equals $5 as a net gain. And so the probability of that happening is 24495. So I am more likely to lose money than I am to gain money there. All right, find your expected value if you bet that on the pass line. So that's going to be, so the expected value here is going to be -$5 times the chance that I win those that I win those -$5 or lose $5, plus $5 times the chance that I win those $5. So that's that right there. And let's see what that equals. So -5 times 251 divided by 295 plus 5 times 244 divided by 295, and I end up getting -$0.11, or -11 cents. Which of the preceding two bets is better in the sense of producing a higher expected value? Well, that would be the craps line. I mean the pass line on the craps table. Okay, then this is basically what we said. There's that. Oh, 7 cents. Why did it say 7 cents? 0.11. What did I do something wrong here? What did they do? What did they do? -5 plus 5. -5 plus it's 5 times. What's 5 times? Did you see what I did? Did you see what I did wrong? Let me show you my work. No, that's the wrong work. Here's the work right here. 2 times 244 over 495 is $2.46. $2.46. And then the other one is -5 times 251 divided by 495. And that's the 253. And then so -2535 plus 2.46. Oh, that's funny. Yeah, I get 7 cents. I don't know where I got the... That's funny. Okay, so -0.7 is what it ought to be. 0.07 7. And so that is negative 7 cents. Okay, is that the end of it? And so here's the interpretation. The $5 bet in roulette results in an expected value of negative 26 cents. The $5 bet on the in craps results in the negative 7 cents. Because you are better off losing 7 cents instead of losing 26 cents, the craps game is better for in the long run, even though the roulette game provides an opportunity for a larger payoff when playing the game only once. Okay, now here's another example. A child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. Let X equal the total number of times per week a newborn baby's crying wakes its mother after midnight. Okay, so X equals all the way to 5. Okay, is this a PDF? So we are given these values. Is this a PDF? Well, it looks like each is in between 0 and 1. Okay, so, so first, is it numerical? Yes. X equals 1, 2, 0, 0 to 5. 2, does it sum to 1? 2 plus 11 is 13, plus 23 is 36, plus 9 is 45, plus 4 is 49, plus 1 is 50. So if I add up the numerators, I get 50. All that over 50 is 1. So yes, that works. And then 3 are all of these in between 0 and 1, each of them. And the answer to that is yes. So it is a PDF. What are the parameters for this distribution? Okay, well, mu is going to be the sum of the values of x times the probability of x happening. So what is that? So 0, so that's going to be 0 times 2 over 50, plus 1 times 11 over 50, because that's the probability of 1, times 2, because that's what x equals, plus 2 times, and the probability of 2, probability of a mother being awoken by its newborn is twice in 1 week is 23 out of 50. That's an empirical probability. Plus 3 times 9 over 50 plus 4 times 4 over 50 plus 5 over 1 times 1 over 50. Alrighty. Okay, and so what is that? That's the same thing as 11 over 50 plus 46 over 50 plus 27 over 50 plus 16 over 50 plus 5 over 50. So let's see. So 11 plus 46 plus 27 plus 16 plus 5 is 105. So that's 105 over 50 is 2.1. So, on average, we would expect a mother in general, if this is a representative sample, a mother with a newborn baby to be woken up 2.1 times per week. All right, so that's mu. Now let's do sigma squared. And so that's going to be the sum. So that's going to be the sum of the deviation from that. So the sum of x minus mu squared times the probability of x. I'll go ahead and do that. So that's going to be equal to 0 minus 2.1 squared times the probability of that, which is 2.50. Plus now 1 minus 2.1 squared is 250 plus 2 minus 2.1 squared times 11 over 50 plus 3 minus 2.1 squared times 9 over 50. And then we'll just dot, dot, dot all the way to 5 minus 2.1 quantity squared times 1 over 50. I put all that in my calculator, and that'll do it. That'll give me something. And then for the sigma, so this will give me sigma squared. Sigma is going to be the square root of sigma squared. And that's that. Let's talk about units. What's the unit on the mean here? Well, that's just going to be the same as the data, hours per week. The units on sigma squared is hours squared per week, and then the standard deviation always has the same units as the data. So that's again hours per week. Okay. All right, everybody, and that's it. Good luck on the homework and on the quiz.